Next up, we have another speaker. We're going to keep rolling through them today. No rest for the wicked, and we're being joined by Melissa. Melissa is a lead developer. I wrote this down. I knew I was going to get it wrong. Down in Melbourne. She also is one of the organisers of the .NET user group and a Microsoft MVP. But today, she's going to be talking about something that I love: JavaScript and Azure functions. Melissa, welcome.
Thanks for having me. And thanks for everyone for tuning in to the Azure Serverless conference today. So my talk is called JavaScript in the Cloud. And really, it's a high-level look at all the cool stuff you can do with JavaScript on the cloud, specifically in Azure. My socials are up on the screen if you'd like to connect with me. I love to connect with people who have similar interests to mine. So please reach out. A little bit more about me. So as Aaron said, I'm a lead software engineer at a company called Xenix, and I'm a Microsoft MVP in developer technologies. I mainly work in application development focused around .NET and worked a lot with Angular and other JavaScript frameworks, and also have been working quite a lot in Azure. And when I've been doing my more recent learning about cloud computing and Azure, I was surprised by how much you could actually do with JavaScript in the cloud. So I put together this talk. So what is the cloud? We know that it's software and services that run on the internet instead of locally on your computer in a big data center, usually run by Azure or whatever cloud provider you're using. And you rent that space and pay for what you use, letting it scale as your business needs change. While cloud providers like Azure take care of managing that physical infrastructure. So really, there is no cloud. It's just someone else's computer. And the other part of this talk is JavaScript. So JavaScript is a lightweight programming language that allows you to implement complex features, usually used for web pages. It runs natively in the browser, and many people, when they start programming today, start with JavaScript. And this is because it's relatively easy to get started, and since it runs in the browser, it's quick to get up and running. And my first experience with JavaScript actually started with this O'Reilly book. I'm not sure exactly what the edition was at the time. But during my university degree, I didn't actually learn any JavaScript there. It was in one of my first jobs in the tech industry while I was still studying. I started at the software solutions company, and I was told that we were using the main stack, which is Mongo, Express, at the time was AngularJS, because the newer version didn't exist yet, and Node, which is all JavaScript-based frameworks for building end-to-end full-stack applications. So I was handed that JavaScript book, and after reading it, trying to understand what the heck a closure was, I was partnered with a senior to do web development. And from there, I've used JavaScript mostly throughout my career, focused on web development. And traditionally, JavaScript is a language for the web. It was created in 1995 in just 10 days by Brendan Eich, who worked for Netscape. It was created as a scripting tool to manipulate web pages in the Netscape Navigator browser, and soon after was standardized and took off to become one of the most popular client-side programming languages, with today 97% of the web using it. However, JavaScript is much more than just a client-side programming language. It was also initially created to be used on the server side, but didn't become popular as a server-side language until later on with the creation of Node.js in 2009. So Node.js is an open source, cross-platform, backend JavaScript runtime environment that runs on the V8 engine and allows you to execute JavaScript code outside of a web browser. And with the advent of Node.js as a popular server-side JavaScript programming language, it opened us up for the ability to use JavaScript in the cloud. And I personally am a really big fan of simplifying the developer experience and using one language end-to-end across your application. And so with the use of Node and all these other JavaScript frameworks that we know and love, it makes it really easy for developers to work across the full application. And you don't have to have the separate front-end, back-end team specialists. You can have all the skills you need to build the full, robust applications and having some of the same toolkits that you're used to working with different parts of your code. And with Node, we can now run our JavaScript applications on the server. And if you look at the major cloud platforms today, JavaScript is one of the supported languages, including on Azure, which is why I'm here talking to you today. Azure Runtime supports JavaScript, but it also supports TypeScript and any other flavor that you love that transpiles down into JavaScript. And in the words of Scott Hanselman, one of the partner program managers at Microsoft, the cloud doesn't care about language of choice. And one of the best ways to use JavaScript is through serverless solutions. So this conference is all about serverless, and serverless means that the cloud provider, in this case Azure, automatically allocates those machine resources on an as-used basis, and they take care of the services and underlying infrastructure for you. So despite the name, there are servers that are still there, but we as developers don't have to deal with them. So it means you can write and deploy your code without worrying about provisioning or doing the admin and configuration of those servers. And they're inherently auto-scaling, and you only pay based on your consumption, generally depending on how you set it up. And this makes serverless solutions very flexible, and it naturally optimizes costs and performance of an application and allows developers to quickly update and release new versions and have a quicker turnaround time to market. And one of the most popular serverless computing is with Azure Functions, Functions as a Service. So we've seen a couple examples already today of how you can use Azure Functions in robust solutions, but Functions as a Service allow you to execute small, discrete pieces of code. They're focused generally on event-driven execution, such as an HTTP call or a timer trigger. For example, you could have a function that sends out an automated email once a week or generates a report once a month, something like that. And when we're using these Azure functions, they are serverless solutions. And they really allow you to create a simplified serverless backend or API layer for your application. And the good news is that all of these functions can be written in JavaScript. So if you want to get your hands dirty with Node, or you're already a JavaScript developer wanting to have the same language across the front end, back end, you can do that with JavaScript and Azure Functions. So you can have a nice cloud-hosted auto-scaling solution for your application. Serverless and microservices also go together very nicely. Microservices are independently releasable services that are modeled around a business domain. And with microservices, we want them to be deployed independently, which is encouraged with Functions as a Service. We want them to be small, flexible, and focused on automation, which when we have working with Azure Functions, we know that's what they inherently are. But also to be a microservice, it needs to be modeled around a business domain. So it comes down to how you actually design your serverless solutions. So they go nicely together, but just because you're using functions and serverless solutions doesn't mean you're automatically using microservices. So you have to focus on making those discrete pieces of code aligned to your service boundaries, and that will lead you to a serverless microservice architecture. And this is an example of what that could look like. So I just took this from the microservice, one of the Azure sample architectures, and this is showing a rideshare application solution. And it's using the fully managed services from the Azure serverless platform. So we have an Azure App Service hosting the application, API Manager, which is exposing the different endpoints and hiding the implementation details. And then we have our Azure Functions for our APIs that are based around different business domains. In this case, it's for drivers, trips, and passengers. And then we're also using durable functions as orchestrator and setting up event-driven messaging service. All these components are scalable and focused around that automation that we want to have with microservices. And most importantly, they can all be written in JavaScript. You can also write it in other languages if you want as well. But this talk is all focused on the cool stuff that you can do with JavaScript. And so you can have these really robust solutions following popular architecture design patterns and taking advantage of all the great stuff that you can do with JavaScript in the cloud. And when it comes to developing these applications and solutions, there are some really good tools and guides out there to help you. If you go to the Microsoft Docs, they have all kinds of quick start templates and learning resources for JavaScript developers in Azure that can help you get started. There's also Azure CLI supports JavaScript, and that'll allow you to create and deploy your JavaScript-based applications with the CLI. Your favorite IDEs, such as Visual Studio Code and WebStorm, also have extensions that let you integrate with Azure and access quick start templates, write, debug, and deploy your code all from within that IDE that you probably already use with your JavaScript application. So let's take a quick look at a demo of what those extensions look like. So I have I've already created a JavaScript function, Azure function, using the templates in Visual Studio Code. So I have the Cloud Tools extension installed. So this is the template that automatically gets generated when you choose Node.js as your language and JavaScript as your language for your function. If I go over to the extension, I can access what I have locally for Azure Functions, but I can also actually see what I have on the cloud. So this is connected to my Azure Cloud instance, and there's a function app that I've already deployed up there, and I can interact with that function from within Visual Studio. So if I wanted to execute this and test it out from my local machine, I can go ahead and do that now. So if we press enter, this will execute. And the template for this one, let's see, we open it here. So it executed successfully. This one, it's doing a hello world, but this one I've said I'm deployed on Azure. So we know it's the one that's on our Azure instance, and it has deployed successfully. I can see if I jump over to my portal really quickly, that's that same one we have here. So this is hitting our Azure instance all from within Visual Studio. So it makes it nice for testing. And if we want to go back to the one that we still have locally, I will close this message. We can run and debug this all within our Visual Studio as well. So if you click F5, you can start running it. And once that's running, you can execute in the same exact way that we just did the one that's hosted on Azure and test it out locally before we deploy it up to the cloud. So I think that might be running. Not yet. What happened? Cool. Well, if it started running, it's being slow, of course. Doing a live demo always makes it a bit slower. But if once you start running, you do it the same way, where you right click and go execute function, and we would see that pop up here. Cool. So it looks like now it's running. If I jump back here and go execute function. And that executed successfully. So if you have some more complex code that you really want to verify and make sure is all working and test it out locally and fix any issues you may have, you can all do that really nicely from within Visual Studio Code. And once you're happy with it, this one is just locally, you can also deploy from within Visual Studio Code as well. You can click the deploy to function app, and that'll connect up to your Azure resources that you have and deploy it onto the cloud. So you can deploy it to a test environment, you can deploy it wherever you want before you get started, and you can manage everything that's happening within these tools that we have here. So it's really handy and nice to work with. And all these templates that we get started. So this template that was created is written in Node, and it's based on the language that you choose when you set up your function app. If we go back to my slides. So another really cool thing is the massive suite of JavaScript SDKs. So the software development kits, the libraries that allow you to integrate with all of the Azure services. So Azure has provided us a huge list of all the SDKs that are available. For example, if you watched Anna's demo earlier, she connected to an Azure SQL database, and that can be done from a JavaScript application using one of these SDKs. And actually, her whole example in solution architecture could be written in JavaScript. And she said she had the different language options there. So go check out her code if you're interested in that. But if we look at, if you end up going to the Azure JavaScript page and looking at all the different NPM packages that are available, this is just scrolling through it just to show you how many there really are, because they make it so that you can do all the things that you want to do with your Azure services from within JavaScript applications available to you through Node packages. And to integrate these with an application, all you have to do is run npm install and the name of the package. So this example here is using Azure Digital Twins SDK, which is part of the IoT solution services that are available on Azure. So you can integrate with all different things such as IoT. And once you import that client package, you can create a new client tool, and then you have access to a suite of all the APIs to be able to update the twins, to insert and create and do all the nice things that you would want to do with, say, your IoT digital twin solution. Similar goes for any of your AI and ML packages. There are SDKs available to integrate with those within your JavaScript framework as well. So this is an example of the Azure Cognitive Services SDK, where you can do some computer vision analysis that allows you to analyze images. So you can do some very, very robust things with your JavaScript applications. And another part, this was also mentioned in Anna's app, is of like really cool stuff that you can do with JavaScript in the cloud is with Azure Static Web Apps. So Azure Static Web Apps are a serverless web app hosting service offering, and it's an offering under the Azure App Service, but Microsoft have extended the managed hosting service to automatically build and deploy full stack web apps from Azure from your repo, using GitHub Actions or Azure DevOps if you want as well, to seamlessly connect static web apps with Azure functions. So it's a fully serverless solution. It gives you a globally distributed CDN and a very scalable backend ready to go. And you guessed it, this can all be based in JavaScript. And the static content is JavaScript based anyways, unless you're using like Jekyll or one of those other frameworks. But generally, you have, say, like your React or your Vue app that's transpiled into JavaScript. Then you have your API layer of your Azure functions, which can nicely be written in Node, and have your end-to-end JavaScript application for that as well. And if we're looking at the Visual Studio tools as well, there's an extension available for you for Azure Static Web Apps that sets it up automatically for you, and that'll automatically create the GitHub action, which helps you quickly deploy your code to Azure. And it'll set up some of the framework and do the same kind of thing that allow you to build, deploy, and debug all from within Visual Studio Code. And the cool thing is, if you do everything end-to-end, say in JavaScript, in Azure Static Web Apps, you can put breakpoints in both your front and back ends and debug them from within Visual Studio. So it's really nice and easy to work with, and really great for JavaScript developers or people who are wanting to work with JavaScript. And it lets you build and deploy everything as one unit. So we mentioned GitHub Actions, so that's part of the solution with Azure Static Web Apps. But it's actually really cool. GitHub Actions is a CI/CD tool to automate, customize, and execute your software development workflows right from within your GitHub repository. And you can actually even write your GitHub Actions in JavaScript. So if you have custom actions where you're wanting to maybe automatically open up an issue with some information, or just print out certain information in a message, you can use JavaScript to write those custom actions. So the JavaScript actions are just programs written in JavaScript that run based on a specific trigger. And it's a modular piece of code, and you can run it directly on the CI server or the build agent. So they actually end up being faster than container actions, which is the other way of writing custom actions. And because this is all part of the Microsoft ecosystem, it all integrates and works very nicely with Azure. I'm quickly just going to jump over to a GitHub action that was written in JavaScript. So the template for the YAML, you still need the YAML template file, but all it does is you're defining the action, and you're defining the inputs to your function and what that's going to look like. This is just a hello world one. So if we go to our main file, all it's doing is taking in those inputs and having some code there. So here it's just doing a console log, we can do really advanced, fancy stuff, such as connecting to different APIs and, as I mentioned, creating issues and all of that. So you can get really creative with what you're doing with JavaScript. So in summary, we have seen how to create a serverless function in JavaScript, how you can deploy it using your JavaScript dev tools, how you could set up a microservice serverless solution, an example of JavaScript SDKs connecting to a cloud service. We've seen a little bit of the Azure Static Web Apps and how you can work with GitHub Actions as well. And there are many, many things you can do with JavaScript and JavaScript in the cloud. You can expand out into machine learning and AI, and you can even go further into the world of gaming and robots and mobile and cloud, because JavaScript is a very, very powerful and amazing language. There's even been a complete implementation of a Linux emulator written in JavaScript. It can compile C programs, support shell commands, and everything, all based on a JavaScript implementation. There is a concept called the rule of least power from Tim Berners-Lee, the creator of the web, that suggests the least powerful language is suitable for a given purpose. As a corollary to this rule, we get Atwood's law, which states that any application that can be written in JavaScript will eventually be written in JavaScript. So I hope if you're not using JavaScript today, that you go out and learn it. You look at all the cool and awesome stuff you can do with it, especially with the integrations that you can have into the cloud and all the different Azure services, because the opportunities with JavaScript are endless, especially when paired with the power of the cloud. So thank you. I have a link there for all of my slides and resources and the different tutorials and stuff that I used today. And I'll take any questions if we have some time.
Thank you, Melissa. It was a very knowledgeable session. I learned quite a bit from it. One thing I personally like about Azure Functions is that I don't have to worry about any certain programming language in order to start running code on it. With that, we do have a question from one of our audience, which is, what is your preference for the Node.js unit testing framework?
There's quite a different range of frameworks that you can use when you're testing JavaScript in general. So I've used like Jasmine. You can use that for Node as well. And a few different ones. But yeah, Jasmine's a really good one.
Thank you. So with that, we have no other questions. So I would like to thank you, Melissa, while we move on to the next session.